All right, going to go ahead and get started. Thank you everybody for joining us today. We are going to be talking about feature management and how we can de-risk releases and migrations with LaunchDarkly, specifically over with our friends from PowerSchool. So my name is Peter McCarron. I am a senior technical marketing engineer for the LaunchDarkly team. That's a fancy way of saying I work on developer experience, try to show you all how LaunchDarkly works and how we can help you. I'm joined today by Adam Hisley. He is the principal architect for PowerSchool. He's going to have the bulk of the presentation, show you all the cool stuff that they did, both internally and using LaunchDarkly. But before we get into that, we have this question that we're all trying to answer here. Why is releasing software so hard? Ultimately, that's why we come to conferences like this. That's why we're trying to figure it out. We want to figure out why is it so hard for us to release software and then also accumulate a bunch of swag. But ultimately, the reason that we fear software releases is because they're fraught with risk, right? We've all been in that process where we push something new, something goes wrong, and ultimately downtime is expensive. If you have an outage, that means that your customers are likely seeing an error, they're getting frustrated, it's going to lead to lost revenues, it's going to be a problem all around. Additionally, if you're grouping everything into a single release, you're ultimately going to have your developers spend more time debugging code than actually pushing new features. And it's because you have everything all in one, you're trying to find like a needle in a haystack when things go wrong. Which ultimately leads to the fact that we say, the status quo kind of works, right? The idea is that we don't need to introduce new systems or new tools because things are working the way that they're supposed to. But that leads to stagnation, technical debt, and ultimately this whole process is just the reason that we don't like to release software. And if you think about it, this is probably what the release process looks like for a lot of folks. You have your development team in the middle there, they release a new feature, they trigger the CI/CD pipeline, everything builds, it deploys, then a bug happens, right? We find an issue, something goes wrong, somebody who happens to be on call gets a nice PagerDuty alert at 2 a.m., everybody's unhappy, and they spend their weekend working triage, setting up support tickets, working in a Slack channel, and then you have to make a choice. Am I going to roll back that feature, or am I going to find the fix and then I'm going to redeploy it? But this whole process slows everything down. And so what we end up doing is we say, we're not going to release all the time. We're going to release maybe once or twice a year or something. And the challenges that are holding folks back are things like unexpected bugs. We've all had that experience, I'm sure, where we say it works on my machine. Right? My local environment, everything was great, but then I pushed it to production and something I didn't catch ultimately failed. The other problem is that it's scary to push new software because I don't necessarily have a control in place where I can limit the impact radius of the people who are going to be affected by those changes. It's kind of like an all or nothing thing, right? I got to release software, everybody sees the change, and then that can become a problem if something goes wrong. And then once the feature is released, how do I actually know that the business impacts are measurable? How do we know what we released is actually helping our customers? Setting up A/B testing, it's complex, it can be a little bit challenging. And then you take this whole piece and you have it split between two different release processes. We have the mobile lifecycle as well as the regular development lifecycle. And there's kind of this fracture between those two where the mobile has all of these other complications in addition to everything you're trying to solve from a general release. And so that's what we're trying to solve for at LaunchDarkly. So at LaunchDarkly, we're trying to help you de-risk releases using feature flags, allow you to be able to release frequently and often with stability. But we also want to help you be able to control that impact radius. So you can feel empowered to be able to roll out your changes to targeted folks, be able to deliver nice customized experiences based on who your users are. And then once that feature gets released, be able to run experiments against it. Create measurable impacts to understand, is this change helping me or is it hurting me? Or do I need to go into a different direction? And then again, we unify it in the mobile lifecycle experience so that we can do the same things for our mobile apps as well as our web apps. And so what that looks like now is this. The developer's no longer at the center of this constantly getting pinged with errors and issues. The developer works on new code. They deploy the feature. We use LaunchDarkly to create these targeted releases. Adam's going to talk about that in his presentation about how they use that to control the release process. If we find an error, we have an automatic kill switch that turns that flag off. We don't have to get anybody paged. Nobody has to work over the weekend. We can resolve it on Monday. We can then broaden our audience. So once we've moved past our testing phase or our early access phase, we can make it available to everybody. And then we can measure the performance through experimentation. And now LaunchDarkly is at the center of that, handling those things. And your developers are focusing more on the code that they want to build and building the features that their customers love. And so the LaunchDarkly platform handles a number of things. If you're curious about what's on here, I know it's an eye chart, come talk to us at the booth. We're happy to answer all these questions. We're going to focus today primarily on that increasing release velocity and stability section. And I've said a lot of words about all this stuff, and you might be saying, okay, well, what does that actually look like in practice? And that's where I want to invite my friend Adam up to talk about what it looks like at PowerSchool. So Adam, hand it over to you.
All righty, thank you. Put this down over here. Thanks, Peter. All right, let's go ahead and get started. So, hey everyone, I'm Adam Hisley here. Happy to be sharing some lessons learned from my team, Naviance, within PowerSchool. So I'm going to talk today a little bit about just a specific kind of feature flag change, and it's one that I think hopefully folks are generally interested in, which is about pulling pieces of a monolithic application out into a service-oriented architecture. And one of the things I really love about LaunchDarkly and feature flag-oriented development in general is that it's applicable to a wide variety of problems. You can use feature flags for individual features on a screen and releasing them. You can use it for ops flags and general even bug fixes. But one that my team has found a lot of value with is this situation where we need to make a big, somewhat ambitious architectural change in our system. And how can we roll that out and release that with high confidence and low risk? Okay, so if you're not familiar with PowerSchool or if you've never heard of Naviance before, know that we're an ed tech company. We're serving millions of students. Our customers are schools and districts, primarily in North America. And if I go to this next slide here, you can see that PowerSchool in general, it's in over 13,000 schools and district organizations across 90+ counties and territories, and the whole PowerSchool ecosystem serves 45 million students. And I think the reason I think this slide is so important is it really hopefully underscores the importance to our team of having really strong, high confidence rollouts, because our software is being used by ed tech customers who are very tuned in. There's usually a seasonal life cycle. They want to do activities at particular periods during the school season. If we have a release and we don't have high confidence in it, or if we miss a key target, that could have a real negative impact on the students who use our software. And so it's very important to us that we get this right and that we can ship with high confidence and low risk. So I'm the chief architect for Naviance, which is one of the product lines within PowerSchool, and serves about, as the earlier slide mentioned, around 10 million students. And so I'm really going to focus there for the concepts in this talk, although all of PowerSchool uses LaunchDarkly and all of PowerSchool does use feature flags. And Naviance is what I consider to be a pretty common enterprise application journey. I imagine this story will sound familiar to a lot of folks here, is that it started with a small engineering team and a monolithic architecture back in 2002. Product was met with success. Schools and districts love using Naviance, so that over time the team size grew. And as naturally happens, time went on. We started getting really interested in cloud-based technologies. Today, Naviance is entirely on AWS. We retired our last data center dependency just a couple of years ago, which was awesome. And as you continue to grow and as you continue to scale up, the engineering leadership within Naviance really starts to focus on this concept of how do we maintain high developer velocity at enterprise scale? How can we be releasing software to our customers quickly at high velocity, as our customer base has grown from tens of thousands, hundreds of thousands, into the millions of users. Okay, and so I mentioned earlier, I'm going to talk a little bit here about moving from a monolithic system with a lot of history into a more service-oriented architecture. And before I jump into that, I just wanted to include this one slide because anytime I say the words monolith and microservice, I tend to find that there's a little bit of a straw man or a caricature that comes up. And just before I go, I want to dispel that a little bit here. When I bring up these terms, I kind of always hear, like, on the left, I have this example of this monolithic application. It's basically a Jenga tower. It's so difficult to touch it. So if you change any piece of it, the whole thing might fall over. Super risky. Stay away at all costs. And on the right, I have the Netflix service ecosystem from one of the talks from the Netflix team, which is kind of like the opposite extreme, the most extreme example of service-oriented architecture from one of the most complicated software systems out there today. And sometimes people will roll this out as well to say, oh, service-oriented architecture, if you start doing that, if you start breaking apart your monolith, this is what you're going to end up with, this crazy amount of complexity, it's going to be totally impossible to manage. And before I start talking about how we break apart a monolith into a service, I just want to underscore this point that, I don't personally think there's a lot of value in those kind of more extreme comparisons. What my team's experience has been, and honestly this has been my experience my entire career, is that really most software systems exist in some kind of hybrid state between those two architectures. Usually there is a monolithic system, oftentimes one that you started with, and there's a kind of trend over time as your team size grows to become more service-oriented. And so, I'm going to describe something that I think is a good fit for that kind of reality, and we'll talk a little bit about why that is. If we dive into what actually happens as a team looks at breaking apart a monolithic application, this slide tries to capture a bit of a heuristic, again, based on my experience, which is that, in the beginning, when you're scaling up your team from small to maybe medium or medium small, adding more developers is fine. You increase the size of your team and your output increases somewhat linearly. You get a good bang for your buck. But eventually you start hitting these inflection points. You start hitting this point where you realize having more and more people contributing to the same code base, the same monolithic system, starts to fall off in terms of the gains that you're getting in terms of output. And under the hood, what I think most people realize who maintain a monolithic system, what you can see pretty clearly is that while you can continue to increase the size of your team, the individual productivity of each member of that team eventually starts to go down. And the reasons for this are probably the subject of their own hour-long talk, so I'm not going to go super deep into it. But I think it hopefully is somewhat intuitive to folks. For example, just the fact that teams are going to be stepping on each other's toes. You'll have code conflicts. You'll have folks who wanted to push a dependency update in your monolith at the same time someone else wants to roll out a new feature. You get a lot of cross-communication and a lot of basically velocity reduction as this team size increases. Okay, so what does this mean for my team on Naviance? Obviously, this means we want to continue this hybrid architecture and move, but I think there's a couple other interesting points that can be made here. The first one especially, which is that if you believe, as I do, that there's this kind of growing reduction in individual developer productivity, then there's an important implication there, which is that you can actually realize pretty significant gains just by an incremental refactoring of your monolithic architecture, right? If the trend is always worst at the tail end of the graph, then backing up the tail end of that graph a little bit is going to give you your biggest bang for your buck. So you don't have to completely rewrite your monolith to get great gains. You can just pick a specific part of your monolith, go there, do an incremental refactoring, and then figure out what to do next. And again, the last point I'll mention here, probably obvious at this point, but what are we moving towards? What we want to end up at the end of that is we want to end up with a loosely coupled architecture where independent, high-velocity teams don't have to do a ton of cross-team orchestration in order to deliver new features to our customers. Okay. All right, so if you're along for the ride this far, and if this sounds great to you, the next question is the actual important one, which is how do you get started? What are you going to do? This is something that's easy to say, but of course there are key challenges when you're trying to look at shipping and releasing an architectural refactoring. The first one here is something that I would highlight that our team definitely believes in. We never want architectural changes, really any, if we can, to prevent us from delivering new features and experiences to our customers. And sometimes I think you hear this kind of sense. I've certainly worked at prior companies where this was the case, where if you're doing a big architectural refactoring, no one wants to touch the product during that time. They just say, okay, let's just focus on doing this architectural change. My opinion, personally, is I actually want to do the exact opposite of that. And I want actually to use an architectural refactoring as an opportunity to deliver new functionality, new experiences to my customers. And I'll talk a little bit later about why I think that's a good idea. The other thing that when we start thinking about doing this architecture, you immediately start thinking about releases. And for me, the maxim here is I really want to avoid this quote unquote big bang. I don't want to be shipping a brand new software architecture to my customers all at once. That's obviously going to be very risky for a lot of the reasons that Peter just described earlier. And so how do we avoid that, right? The last 2 points I'll mention here are specific to this use case of really wanting to touch an older system. Older systems have less reliable regression testing, and they also have lots of data, right? Lots of older data. In Naviance's cases, 20 years of it in some places. And so for us, that represents a pretty significant concern in the sense that you might not have great testing coverage. You might have lost some domain understanding over the years. And so when you release this in a new iteration, in a new architecture, in a new data model, you might get surprised. You might learn something you didn't anticipate in your lower environment. And obviously, you want to have a plan for that. Okay. So something that my team has done over the years and effectively has become kind of like a blueprint for us in terms of doing this type of architectural modification, again, iteratively, opportunistically, is that we really focus on 4 key pieces. The first piece being a concept, and we'll look at these in the following slides, but the first one being this concept of a micro front end. The second part being a domain API, which is basically an independent backend that we want to break out into. The next piece being a new database and a data migration strategy. And yes, we do that. Some teams I know might hesitate to move data. I mentioned in my last slide, data is hard. But I really think that's super important here, actually, because as I mentioned earlier, what we want is a loosely coupled architecture. And if you don't have an independent data store, you're always going to have that area of tight coupling. And that's always going to be a risk for you, and in some cases, a pretty severe one. So we do that as well. And then the last piece that ties this all together is a very specific tiered release strategy where we really think from the beginning about how are we going to roll this out to our customers, how are we going to effectively deliver this new architecture. The diagram on the right, we'll see a little more of a drill down into this in a moment, but just at a high level, at a 10,000-foot view, what it shows there is that we're using Launch Darkly, and specifically feature flags within Launch Darkly, to take our user base and cut them over from a legacy experience, imagine like a 1.0 experience, something that was created a while ago, into our new user experience on our new architecture. And again, we'll look a little bit more at how that happens in depth. So going down the line here of the pieces of that blueprint, the first one are this concept of micro front ends. And this is an industry term. You may have heard this before. If you haven't heard of this before, the high-level concept is really that you want to take your user interface and you want to break it out to make it a loosely coupled component so that your UI is not a build time dependency of your monolith. And for some people, this may be obvious. Of course you should do this. But I've definitely worked with teams at the past who built an awesome, loosely coupled, service-oriented architecture. But when it came time to modify their user interface, well, we left that in the monolith. We didn't want to break that out. If you do that, the risk there is that you can really undermine the value proposition of your architectural migration, right? Because you can basically be left with all of the roadblocks of shipping your monolith. It's still your user experience, which is the thing you really care about, is still in your monolith's path to production. Micro front ends basically give you a way to pull that front end out, make it standalone. I don't have time in this talk to go through the details of exactly how we do this. It can be as simple as just an import JavaScript file, instead of bundling it in your build process. If you're really curious about this, find me after the talk, and I'm happy to share more details about that. But if you think about how this works, in terms of enabling and rollout, this diagram kind of gives a quick look at that, which is we want our customers to go into our monolithic application, log in, reach a point where it may be time to show them a new UI, a new user experience. Our monolith code is going to check a feature flag on Launch Darkly. That's the enabled check right there. And if this is enabled for the current user, we're going to send them over to the micro front-end experience. In addition, and this part is important, the monolith may also want to use that feature flag evaluation itself to show a couple new, for example, navigation elements. Maybe there's a banner saying, hey, there's a new experience, come check it out, right? So the monolith may use this feature flag as well, but then when it comes time to actually show the user the functionality, they're going to see a front end embedded within that monolithic application, and that front end is going to call our domain API on the back end. One last thing that I'll point out here is you can see that the domain API in this case and the monolithic application both talk to LaunchDarkly. And that's a kind of key point here, may not be immediately obvious why that's important. We want to make sure that as we're rolling out features to customers, both the monolithic application and the domain API are respecting those feature flag settings. Basically, this helps to prevent a scenario where maybe your customers are comparing bookmarks with each other. Hey, I just saw this new experience. Can you get to this? Oh, yeah, sure. Here's the URL. We still want to make sure that if you're not in the cohort that is currently have access to this new experience, the domain API on the back end will block that traffic and say, hey, sorry, you have to come back later when this is available for you. And that's really important to have a central place where we can orchestrate this because, again, we want these to be loosely coupled architectures. We don't want our monolith and our domain API blasting tons of calls at each other to figure this stuff out. We're very happy to offload that work to LaunchDarkly and just have it take care of it for us. I mentioned data, and I mentioned data migrations. This slide shows basically an AWS service diagram of how we do most of our data migrations for these kinds of projects. We're at AWS reInvent here. I want to preface this slide by saying that probably AWS has released 2 new data migration tools by the end of this talk, and I certainly do not want anyone to assume that this slide is the only way to do a data migration. Or even maybe the best architecture to do one. But it's one that's been very effective for our teams. Effectively, we're big fans of serverless. So what you have here on the left is a data export from our monolithic database where we're using AWS Lambda. We're creating data export files, putting them on S3. Then we're using EventBridge to do an event trigger where on the other side, in our domain-based application, there's an EventBridge listener and a step function orchestrating quite a lot of work sometimes to import that file. And this might be the point on the right where you might do some data model changes. You might be doing some transforms on your data. You might be building a new user experience where you want to translate certain data points. And so we're using step functions for that here on the right. Again, lots of different database migration technologies. By all means, choose the one that your team likes the best. But the thing I really want to call out here, first off, is the fact that once again, as we saw in the previous slide, we have these 2 systems that we really want to be loosely coupled, right? There's a nice, clean event differentiation between our export and our import systems, right? But we need the ability to make sure that the feature flag that controls whether this should be happening for you or not as a customer is respected equally on both sides of the equation, right? So we have this loosely coupled system, but we need this centrally organized way to manage the release and rollout, ideally on a per customer basis. And we use LaunchDarkly for that. It works great. It's a central place where we can align all of these concerns. The micro front end that I talked about earlier, the domain API, and our data migration can all rely on LaunchDarkly to tell the state of, hey, whose data should be migrated, who should see this new user experience, all in one place. And so I mentioned before that, there are different ways to slice and dice this architecture, but really here's the thing that I would call out based on my team's experience that really leads to designing robust data integrations and having high confidence when it's time to roll these out to your customers. The first line here, something we ask all of our teams when we're building these systems is, can I migrate data for a single customer or a segment of customers at a time? And this may not be something that your team initially thinks of when they're building this kind of data migration. I think the first impulse is, well, I've got this database here. I'm going to move all the data over there, and hopefully that'll be it, and I'll be done. But in reality, what really often happens, especially on older systems, right, is you end up in this scenario where a lot of times there are data peculiarities that are specific to certain customers, right? If a certain customer has been using the data for 15 years and they've set up their reporting in a very specific way, or they know of their metrics looking a certain way, it's very often that you might need to deploy a bug fix just for a single customer. And so having this capability in your data migration, being able to rerun your data migration on a per tenant basis, baking that in is really going to give you a lot of flexibility. Hopefully you'll never need it, but if you need it, it's there, and it's a really great thing to have baked in from the beginning. Another thing here is that can I rerun my data migrations easily and rapidly? The architecture I showed earlier, being all keyed on events and this data file concept, does make that easy for us. Another thing that you really want to be ready to do from the beginning here is to be ready to say, hey, if we deploy a bug fix and imagine a beta testing customer or something sees some issue, reports it, and you're able to ship a change, you don't want to wait a week to then say, okay, we think we fixed it, reach out to the customer again, see if it works. You really want to have a really quick turnaround time. That's going to give you, again, high confidence that your fix actually works, and it's going to lead to a better customer experience. And again, those bullet points at the end here are kind of reinforcing some of these things I've said where, when you run this type of re-architecture in production, you really want to expect the unexpected, and you really want an architecture that is going to be flexible enough to really give your team some powerful tools to say, okay, take this person out of the data migration, put them back on the old experience. I deployed a bug fix today. Okay, now remigrate their data. It should be changed, and now put them back in, right? And so this is something that we plan for from the beginning. All right, so I've mentioned a couple times this release strategy, this concept that we are slicing and dicing the rollout here. What does that actually look like for us? And this is actually something that all of PowerSchool generally follows this strategy, where we tend to release our software, not just big architectural refactorings, but really features in general, follow this pattern. And so the first line item there is something we call internal evaluation. And Peter mentioned an awesome thing called testing in production. If you don't know what that means, the ability to have a isolated from your customer's production environment where you can flip on a feature flag and test something is something that we found to be tremendously valuable. And so, Naviance is a multi-tenant SaaS application, which means that when we push our code, it's available to all our customers, unless it's behind a feature flag. And so, what that translates to for us here is we actually have in our production environment dummy school districts, dummy schools with completely fake randomized data that are purely for the purposes of our own internal testing. Which means when we roll out a new feature, we can enable that feature in an internal-only school in production, and we can basically throw user acceptance testing as well as functional testing at it. Again, the goal here is to really improve your team's confidence that when you flip it on for the first real customer, everything should be exactly the same. It's the same exact infrastructure, it's the same exact code, you've already validated it. The next step after internal evaluation is beta or some early access. And this is where we get usually a collection of early adopters, schools and districts who are really interested in getting their hands on some new functionality that we've rolled out. And this is a great thing to have because these are customers who are usually highly interested in what you're doing. They're going to give you a lot of feedback. They really want to work with you. They may be interested in the change you're making, so on and so forth. If you remember earlier, I mentioned that I don't like to make architectural refactorings completely independent from product changes, and this is the reason why. It is very hard to get interested early adopters to come try out your new release if your new release doesn't have any new features for them. If it's just an invisible lift and shift of architecture. You're not going to get any early adopters. They'll just wait as long as they can, and you'll have to do something behind the scenes. It's really nice when you have these interested beta early access customers, and also it's the right thing for the customer, of course, because it's giving them more features, more functionality. The third item here is after we've exited this beta early access period, we enter into controlled availability. And this is where we're using the power of LaunchDarkly, really at its full potential. We're creating user segments, usually for schools and districts, although LaunchDarkly gives you a lot of capabilities here. We've also done state-based rollouts. We've even done individual tenant, targeting rollouts. But basically, we're creating a go-to-market plan where we roll out, by different segments, this functionality, switching over from the legacy experience to the new one. And, there's a ton of advantages to this, but I think if you think about ed tech in general, you can probably see why this is really important for us. Schools and districts are working on a seasonal cycle that isn't exactly the same between all of them. A lot of them have very specific plans at very specific times of the year for when they want to use your software. And so being able to accommodate that to a degree, being able to work with our customers to ship new features at specific times has proven incredibly valuable for us. It allows us to have a release that really meets our customers' needs while having the nice side effect of slowly rolling out code so we can get on top of bugs faster in a smaller, more controlled population, before we go full. The last step here is general availability. This is the end of controlled availability. This is when you have effectively feature flagged on, the new experience for all of your all of your customers. And that may seem like, okay, job's done now, right? It's available to everyone. Who cares about feature flags and all this stuff? But there's one key thing that I really want to highlight here that's really a lot of value add, is that when you hit general availability, having a feature flagged architecture allows you to do quick and easy rollbacks, right? So what's going to happen is when you're in your general availability, there will be customers who may not have seen your new experience yet. There may be schools and districts who are simply too busy. Your team tried their best, but they only get to it, a few months in, and as soon as they do, they raise an alarm saying, hey, there's something here that's not working for us. This has broken our reporting. We need some help. Having that feature flag in place is, this is not the first line of defense, but it's a great last line of defense. If you absolutely have to, roll something back, again, while you're pushing a bug fix out for someone, restoring something for maybe a week and then flipping back over, this is still something that we take advantage of in very rare cases, even when we're in general availability. Okay. And this slide, I think, I've mentioned this the fact that we're moving to this new architecture. This just gives a couple statistics of what this looks for us. I just thought it might be helpful. The goal here on the engineering side is really to have, building out in this new architecture, a slimmer distributed system where we can really take this opportunity to level up our technology practices. And so you see a lot of things there that are consistent across us applying this pattern. It gives us this capability in a loosely coupled system to make significant engineering changes that are great for our velocity, great for our developer happiness, and great for our ability to deliver features to our customers. Okay. And so having applied this pattern over several years now, I think a couple of things that I would call out about this, why this has worked for us. First off, the fact that it's fundamentally iterative is huge. We're not trying to, boil the ocean, reduce a monolith in one giant project into 10 services. This is really something that you can do opportunistically, piece by piece, identifying the right domain, the right module within your monolith, not just for your engineering team, but also for your business. And, it's very flexible. You're not locked into one, giant project, in 5 years or something crazy like that. Another thing that I think this really has been an important lesson for us is that when my team started thinking this way, we really started to realize that a good software architecture was in fact synonymous with having a strong rollout plan. And I think before we really went in on feature flags and really started thinking in this way, there's a kind of unfortunate isolation that happens where, you've got your architects, you've got your engineers, they design your software system, and then there's someone over here who's figuring out the go-to-market strategy and how to tell the customers this is coming. And those two worlds don't interact all that much, right? By doing it in this way, what we really realized is that actually engineers want to be thinking about the rollout process, especially if it's going to allow us to have higher confidence in our release and an easier path to bug fixes and better ways to get customer satisfaction. People are happy to use this, and also thinking about this from the beginning really forces us to design higher quality architectures because we're thinking from the beginning of like, well, how will we do a rollback? If we migrate the data in this way, if you do it that way, you won't be able to roll back actually. Like having those kinds of design conversations early and up front means you don't have to have them at the 11th hour when someone's called you with a massive production bug. So, really something that we've, has become, again, synonymous with our architecture design process. And then the last point here, I really can't say enough about internal testing in production and how much extra confidence that gives you. Of course, we are also testing, full automation testing in a lower QA environment. and end-to-end integration testing and all that stuff. But there really is, in my opinion, no substitute for saying, okay, when I turn this on for a customer, all I'm doing is flipping a feature flag. I'm not pushing new infrastructure. I'm not deploying new code. The decoupling of deployment from release is really a tremendous value add here, and it really improves your confidence when delivering to your customer. Okay, so I mentioned that my team has been doing this for a while on Naviance. Since 2019, which is when we started with LaunchDarkly, and we actually started doing this type of re-architecting, a little bit after that. The team has built out 9 domain services, this is specifically the pattern where we're pulling modules out of our monolithic application. So of course, we've done other developments since then, but this is really focused there. And I call back to earlier when I said, the kind of against the caricature of monolith and microservice here. I don't really think that this means that monolithic architecture is bad, and the proof for that is that we've actually had double the monolith commit rate since we've started this journey, and in fact it's a little bit better than that. It's actually more year over year. The point I want to make there is that doing this kind of incremental refactoring has improved our ability to work on our monolithic code system and to push code and features out to our customers, and maybe that seems a little unintuitive at first, but in practice, honestly, I think that's actually, not surprising at all. Basically, we've taken features that would have been distractions from our teams who understand our monolithic code base best. We've moved them into loosely coupled architectures where those teams can work independently, and now we've got, our teams really focusing on improving the code that is in our monolith and not, orchestrating massive release discussions and, giving best practices information to other teams, so they're just able to do more work. And alongside that, just as a statistics from 2022, we actually deleted 150,000 lines of code from our monolithic code base as a result specifically of these kinds of refactorings, where we were able to pull the system out and make it independent, which again, I am 100% sure that improves our commit rate, one way or another. Just less code you have to think about, easier to keep the system in your head. These are things we're really happy about. And of course, as I've mentioned here, LaunchDarkly has been a key part of this process for us. They've been there every step along the way. We use LaunchDarkly for more than just this type of architectural change. We're up to hundreds of feature flags that we're using to maintain all kinds of different things that we're shipping. And we use user segments. Last I checked, we had over 20 for our most recent release. Okay. All right, and then this is my last slide before I'm going to toss it back to Peter for a little demo here. I would definitely be remiss if I didn't talk about LaunchDarkly and this kind of developer experience and also talk about team sentiment. So what you're seeing here is the outcome, and I apologize, the text is probably a little small, so I promise I'll read it. But what you're seeing here is the outcome from our annual developer sentiment survey. And so this is something on Naviance that we do where we send a survey out to all of our engineers every year to ask them, hey, can you rank all of the tools that we're using? And this is not just for vendor tools like LaunchDarkly, this is also for like AWS CDK, if we're using TypeScript, everything. Year over year, every year since we've started doing that survey, LaunchDarkly has ranked in the top 3 and sometimes the top 1 in terms of developer sentiment for tooling and experience. And I could talk for a long time about why I think that is, but the reality, the important point, the reason I share this is because I'm 100% sure that that's been a critical factor to our success here. That the ability to have released these domain services, completed these refactorings, and shipped them to our customers successfully is the fact that our engineers enjoy working this way. They like building systems this way. They like having access to LaunchDarkly. They like being given a kind of powerful tool that really gives them a lot of capabilities here. And that's been reflected, like I said, every year we've done sentiment analysis. All right, and so with that, I'm going to pass the baton back to Peter, who is going to give a demo of what this actually looks like, an example doing a migration using LaunchDarkly. And I think, Peter, you're even going to show some functionality that was new, released this year. So I'm actually going to be watching as well. I'm very interested.
Absolutely. Thanks, Adam. All right. Always love seeing these stuff in the real world. That's always good. So we're going to flip over our monitors here, and you're going to see a very cluttered screen that it's going to make sense in a second, I promise. So I went ahead and recorded a video because I'm not attempting the live demo gods on this one. So what we're looking at here is in this convoluted mess, we have a production cluster of a Kubernetes environment. That's what's running on the top left, that terminal. We have a testing cluster that we're doing, and then we have the applications that are running in each one of those clusters. Those are the little hang tight things. And then we have our launch darkly environment. Now, one of the things that Adam talked about was this idea of releasing incrementally, right? Having that release process. Well, one of the things we heard from customers is that if I'm going to release a new feature, how do I know if I'm releasing it in my test environment, or how do I know if I'm releasing it in my production environment? How do I keep track of that in launch darkly, and how do I keep track of the statuses? So what you notice here is that I'm in my test environment where I'm going to be releasing this new capability. And if you are seeing something new that maybe you haven't seen before, there's this little test cluster. So remember, right, I talked about that test cluster, then we have production, and then we have this release thing. Well, at Galaxy, we introduced this new capability called release pipelines. And what release pipelines are is a way for you to track what the status of your flags are in your different environments of how you release your software. So what you're seeing here on this big long list, this is the custom release pipeline that I created. It's our very fancy release pipeline. It has 2 stages. We have our testing cluster as well as our production cluster. And then those are all the different flags that you saw on the home screen and the current statuses of them. So what we can do is we can see, have we actually released it into that environment? What percentage have we released it into that environment? What variations are we serving? This allows us to have that visibility to know when features are getting released to our different areas. So we're going to click over into our release new website flag here in just a moment when past Peter gets there. And now we're going to, again, we're in our test environment and we're going to release our new capability. So we release our new website. We see it pop up on the top there, and it's for a new to-do list that we're going to be utilizing where we say we're going to store more tasks in the cloud. But you'll notice that the bottom cluster hasn't changed yet, because we're not actually releasing that software yet. We're using a different SDK key. We're using our production environment for that. But this allows me to be able to release to that testing cluster, make sure that everything's working properly, and when we get the QA thumbs up, we hit complete. Now we're saying to the rest of our teammates that we know that the production is ready, but you see that the flag is still off in that production environment. This is a visibility thing. This is where we can have that communication so that all teams are aligned like we were showing previously, or like Adam was talking about with his team. So now we're going to turn this on for our production cluster. And we say the website is ready. I know it looks really fancy in that very small box, but trust me, it looks cooler later on. So we turn that on, and we see that gets released, and we say, okay, good. We're seeing the same behaviors. We're seeing the same information that we wanted to see previously. So we're ready to go ahead and mark this as released. And we get a nice little thing here that says, hey, congrats, we've released. And then what you have is it tells you when the feature was released. So using release pipelines, we can know exactly what the status of our flags are in our different environments, and we can make sure that our features are getting released in the correct way. This allows us to be able to simultaneously make different changes, do different testing variations. So let's say we go back to our test environment. We're at reInvent. We have this wonderful, purple-orange gradient. Maybe our text should look like that. But again, notice that it changed only again in our test cluster versus in our production cluster. So that's the separation piece. So as you have that release process, you can utilize different launch darkly environments to be able to release features. So let's clean that up a little bit, and now we're going to have just the dual screen. You don't have to squint as much. So we're in our test cluster again. We see our nice little, reInvent gradient text that we have. And one of the other things that Adam talked about was this idea of using information about your users to be able to control access to new features. So we have this new web form that we're going to be launching. The one we have right now is for a very basic to-do list. So let's just see what we have in our current state. So we have it's a very complex, so be careful to follow along here. This is our new to-do list. Let's see what we have to do. We have to first say, hello, reInvent. So, hello, reInvent. It's the very first task that we want to make sure that we complete on this. And then what we do is we cut it out of the top box and we paste it in the other one, and we get a nice little check mark. Very fancy to do. That seems to be working well, but I think we could probably get a little bit better. We could find a different system that's going to allow us to be able to utilize that. So we're going to go ahead and turn on that new web form to see what could we do as an improvement. Maybe we should be moving our back end so that we're actually storing those tasks somewhere else. But we want to make sure that it's for the right users, so we test it first with a cohort. So we can create these rules where we have those user segments, and we can say that only our early access users are going to get the ability to see that new web form. We'll turn that on, and then we'll go back to our application here. Gotta click out of it. So I open this up. Notice I put in a different ID. We see all the information that's still there. We're all still sharing the same web form. We'll refresh our page here. Excuse me. And then I'm going to use my admin login because I'm one of the early access users. Now I have a different web form. And what this web form is doing is this is actually talking to a different database. So I'm going to open up a different tab here where I show you our new database backend. And this is going to be talking to a local Postgres database that's running in that same Kubernetes cluster. And now we have our completed checkbox, we have our ID, our timestamps. So again, we're going to add our previous task of saying hello to reInvent. Submit that. We'll grab our data, and there we go. So now we're storing our information actually in the Postgres database instead of just using a couple of text fields in our box. So we think that is probably a better thing. We said hello already, so we can check that off. At this point now, though, like Adam was talking about, we may want to move our systems eventually. So right now, we're using this in a Postgres database that is currently in that same Kubernetes cluster. It's working fine, but pods tend to crash. And so we may not want to have our data storage in something that could be a little bit more fragile. Maybe we're looking for something that's a little bit more scalable. And we're going to actually switch over to, say, DynamoDB, right? So we're going to show that we have the DynamoDB as an option. And in the past, what we could have done is we could have used different flag logic to change our API. So just to show, we're going to say that we're checking out our to-dos in Postgres. And that shows that we're storing the information there. And if we switch over to the Dynamo table, it won't actually be there. So the idea here is that when we initiate the migration, now we have a new flag type called migration flags. And what migration flags is that they utilize the LaunchDarkly SDK to essentially create stages of migration. In this particular one, this is a 4-stage migration. We offer 2, 4, and 6-stage migrations. And each of those variations is going to do a different thing. In the off variation in our 4-stage, that means we're going to use the old system entirely, so like we are storing in that Postgres. The shadow means that we're going to start writing data to our new database, but then we're only going to be reading from the old one. The live means that we're going to start reading from our old database, but still writing to our old one just for security. And then finally, the complete is when we're going to fully shift everything over. The advantage of doing it this way is we can do things like run consistency checks. We can get things like latency results. We can find out about error rates. This allows us to be able to have so much more control over what our users are seeing, and we can do it in a percentage rollout. So these cohorts are what we can group by. We could do it by email address or school district or whatever type of context kind that you want to utilize. So we're going to change this now to where we're writing to our new database, but we're still going to be reading the results from our old database. So I'm going to update this. We'll go back in and add a couple more tasks. Okay. So if I refresh the data here, you'll see we have starting our tasks in Postgres. That's the one that's currently working for us. Gonna go ahead and enter another one. So adding another to-do. Again, we'll see that show up only on the Postgres side. The reason here, again, is we're writing to the new database, but we're only retrieving from the old database. And this is important. The reason I'm kind of putting these in, I have those extra ones, is because we're going to illustrate that point in just a moment. So once we see that there's no information over here on the other side, we're going to go back to our migration flag. Now, one of the things that I love about these migration flags is the fact that you can get those metrics. Automatically, we will track things like error and latency. You can have your own custom consistency checks. So I don't have that right now because we're just writing different data. And unsurprisingly, calling to the local Kubernetes database is going a little bit faster than going out to the cloud. But that's okay. We knew that was going to happen. We're seeing a lower error rate, so now we're ready to test this live and see what happens when we change over our different systems. So we're going to update this. We're going to go add another. We're going to retrieve this data now. And you'll notice those two that we had written earlier are in the Dynamo table. So we're receiving that same information where we had previously written it to the old database and we were retrieving it from there, but now that we've moved to live, we're retrieving that information that we had already written. So this is how, again, we can make sure that it's a smooth transition, and if anything goes wrong, we can always remove it afterwards. Now that we feel pretty good about it, we're going to go ahead and set another to-do where we say goodbye to Postgres. So eventually we'll be able to deprecate that pod. We're going to refresh this, and then you might be surprised to see, oh no, our data's gone. That's to be expected because we called to that same API and we're no longer calling from our Postgres database. We're only calling from Dynamo now. The information is still in that. If I were to bring up P-SQL and actually show it to you, there is actually data still in there, but we're not pulling that information anymore. So if everything looks good, we can go ahead and switch this over to 100% complete. And go ahead and save that. And then we're going to flip this table, or we're going to say we're fully on Dynamo now. I think that was the last one. Fully on Dynamo. And we see that everything is working correctly, right? So I know this is not like the craziest migration story that has ever happened, but it illustrates a point that we're trying to make it simpler. Now we're going to go into the code base to prove to you that I didn't just store everything in a text field actually in the application. What it looks like is this. This is the node server. This is a node server file, so we're using the node server SDK for it. What we've added is this new capability where we can set this config definition, where we're setting these LD migration options. And within that, there are going to be 4 function fields that we can utilize. So there's a write old, write new, read old, and read new, right? So the 4 things that we would expect as part of those stages. And what we do is we define the logic of what we should do when each of those functions get called, and then we're going to initialize this migration as part of the SDK initialization. It's in this block that we can also put things like consistency checks and also make sure that our error rates are being tracked. So we see our latency tracking and error tracking will always default to true, but you can always add that in there. But this is where you can add any other custom configurations. And then if you see, we initialize the client like we always have, and then we initialize the migration piece. Now in our route logic, instead of having to do all that other pieces, we just do this migration.write, the name of the flag, the migration flag that we're using, and the information that we're going to be sending. SDK will automatically know which one of those functions that it should call. And the same thing with the migration read. So that's how we do the migrations. We're really excited about this. I know that's a very quick overview. If you all have additional questions, feel free to come and do it. But the last thing I have to do on this specific demo is it wouldn't be a solid demo if I didn't have a shameless promotional plug. So we're going to use a feature flag, of course, to set that up. Turn our flag on. I'll tell you to come see us at booth 784. Have to do that. So ultimately, though, that is how our flags work. If you think about it, we're trying to make it easier to follow your own release processes. We're trying to make it easier for you to migrate systems. If you have additional questions on how that is all set up, definitely make sure that you come find us. And it looks like we're going to have a little bit of time for some Q&A, which is great. Ooh, got a little shock there. All right. So as I said, as Toggle gave a thumbs up, we are at booth 784. Thank you all for watching, but we can take a moment. We can answer any questions that you all might have. And if we drift a little bit over, we are happy to meet you outside.